Welcome back to our statistical learning session. Today we'll be talking about a delta method. Initially, to begin with, we have this we have this expression theta n theta hat of n minus theta is a normal distribution. That's what we have. We want to prove this hypothesis. How do we do that? It's a hypothesis, and we want to prove this. We want to test this hypothesis. For that, we need to start with the delta method. And do we know delta method? Yes, we already dealt with before. So we're going to use it now. Here, before we delve into that, we have to understand that theta hat n is a MLE, and it can be an average or any kind or some kind of estimation that will allow us to say that it converges into some asymptotic normality. So we start, then we apply a function g on top of this MLE, and it becomes a g of theta hat theta hat and g of theta, and that will give us a some kind of a product called gamma of theta, which is basically a product of g of theta and sigma of theta, and this is in one dimension, which is the variance. And when we do this, we assume that sigma of theta is invertible and g of theta has rank n, and this will allow us to say this, that this n is of k. This allows n of k. Therefore, these two are really strong assumptions here, that sigma of theta is invertible and g of theta has rank k. And this will give us this value. Now, if this is invertible, then this value also becomes invertible. That means that we can move this value out of the bracket and bring it here. That is, we can rescale the g of theta hat minus g theta by gamma minus 1 by 2, power 1 by 2. And what will give us? This will give us that the whole expression will converge into some standard normal. That is a nk, and it has a dimension of ik. That is a value of 1, covariance of value of 1, and this is the standard normal distribution. And this is what we have done so far. So let's recap what we learned today. We had this hypothesis that theta hat minus theta is an asymptotically normal. To prove that, we need to apply some delta method. And delta method gave us a expression that g of theta hat minus g of theta is some kind of a nk, some kind of asymptotic normal with a variance of gamma of theta, which is a product, which has a certain product, given that, with the assumption that sigma of theta is invertible and g of theta has a rank k, and that gives us nk. It is a standard. It is a normal of it is a Gaussian of nk, and then since we had those assumptions, this allowed us to have gamma of theta being invertible, and that allows us to bring it outside the bracket and rescale the g of theta hat n and g of theta, and that gives a standard normal. So that's all for today. I'll see you next learning session. Have a good day. Thank you.